Hello everyone, I'm Huibert Mees and welcome to 901 Woodworking. It's been a while since I've put out a video, and today we're going to be starting something a little different from the usual wine barrel furniture. Having made a lot of wine barrel chairs, tables and other things, I've ended up with a lot of wine barrel tops and bottoms. I use them for tables, but I still end up with many of them, and it got me thinking about what I could do with them. I volunteer with a charitable organization in my spare time, and their logo would fit perfectly on a barrel top. Of course, this would mean a lot of hand carving, so I got to thinking it would be great to have a CNC router, and what better way to get one than to design and build it myself. So that is what we are going to start today. First, I'll go through the design, and then in subsequent videos, I'll go through the build process, the electrical hookup, the setup, and finally, the first milling. Let's head to the computer to have a detailed look at the design. Here we see the complete machine. I'm using Fusion 360 for my CAD program because it is easily available, very reasonably priced, and super powerful. I haven't found anything I've wanted to do that it couldn't do. Since it had to be able to accommodate 24-inch round barrel tops, it ended up being quite large. The bed is almost 33 inches by 48 inches, and since most of the cost is in the stepper motors, the spindle and the electronics, making the bed large didn't add very much cost. Making it 3 by 4 feet instead of 2 by 2 feet added maybe $100 to the cost. It just means the machine takes up more space. Before designing the machine, I watched a lot of YouTube videos and took the learning from those to decide what I wanted to do. I'll put links to them in the description. The result is that the main structure of the machine will be made out of 60 by 60 extrusions bolted together with corner brackets. It will use 2 stepper motors for the y-axis, which is the long axis, so that there is no chance of the gantry racking as it moves fore and aft. The stepper motors are closed loop motors, so the position will be accurate. The main structure of the gantry is made up of 2 4.8 millimeter thick steel plates with 2 30 by 150 aluminum extrusions between them. Corner brackets between these parts will help ensure a lot of stiffness in the assembly. Stiffness is the name of the game here because I want to be able to mill aluminum with this machine, but even milling hardwoods puts a lot of load on the spindle, and if the structure holding it all together isn't really stiff, the cuts won't be accurate. The Z-axis is made from 2 30 by 60 extrusions held together by 2 half-inch thick aluminum plates top and bottom. The spindle itself is a water-cooled 2.2 kilowatt variable speed unit. Many DIY CNC routers use a router body such as a Makita or DeWalt, but based on what I've learned, a water-cooled spindle is the preferred way to go. They are almost silent, and knowing how loud routers can be, I decided to go for the quiet option. All 3 axes have limit switches that activate when the motors try to move too far. These switches also serve as homing switches to let the controller know when the unit is in the home position. Everything rides on linear rails using HDR20 bearing packs. These puppies have zero play in them, so there should not be any lost motion. The same goes for the ball screws. I chose ball screws over lead screws because they have less friction but are still dead accurate. With any machine this complicated, there are a lot of little parts that need to be made, such as brackets, spacers, and plates, and these I've made myself. The larger, more complicated pieces, like the 2 steel vertical plates, I send to Send Cut Send, which made them for me in about a week. They provide an awesome service that I highly recommend if you need parts made. I'm not being sponsored by them, I just like the service. For other pieces, I bought material of the right thickness and am cutting and drilling them in my shop. Fortunately, carbide woodworking tools will also cut and machine aluminum very nicely. I'll show you some of that in another video when we get to the build process. Of course, there are lots of screws and other fasteners, cap screws, bolts, T-nuts of varying lengths that are required. The last part of the machine is the main board that will hold the workpieces, which consists of a base board, 4 T-slots for hold downs, and foil boards that sit between the T-slots. The spoil boards are meant to be sacrificial and will be easily replaced once they get too damaged. Then there are the electronic components. I put these on a board and tested them to make sure I had everything wired correctly. The 4 stepper motor controllers are along the top, The large box on the left is the VFD that controls the spindle. Here is the 48-volt supply and a smaller 24-volt power supply as well. The other board here is the breakout board that is required to translate the commands coming from the computer to signals for the individual stepper motor controllers. This board also connects to the limit switches. That's what the 24-volt supply is for. As well as the modules to run the CNC, I needed a computer to run the G-code and tell the CNC what to do. This presented a bit of a problem because the code everybody uses for these machines is a program called Mach 3, and Mach 3 has been around for a long time. It was designed to run on 32-bit machines or those that can emulate a 32-bit machine. That unfortunately excludes almost all computers built after 2015, or so I've learned from YouTube. As it turns out, I have an old desktop computer that I dusted off and got running again. I lost the case for it long ago, so I'll have to keep dust out of it some other way. I found a cheap monitor on Nextdoor, hooked up an old keyboard and mouse, and I was off and running. The very last thing to consider is that the spindle needs a source of cooling water. This consists of a bucket of distilled water, a submersible pump, and some tubing. Now comes the question of where to put all this stuff. Since the modules needed to be close to the machine to keep the wire lengths as short as possible, I decided to build a box that the machine could sit on and would contain all the electronics as well as the computer. With some wheels added, it can roll around the shop if needed. I included a drawer for the computer so I can sit on a stool and work. I also added a drawer on the other side for tools and router bits. Underneath is the computer and the bucket for the cooling system. The board holding the electronics sits on drawer guides so I can pull it out and get to all the modules. I'm hoping that with a dust collection system and keeping the drawers and doors closed, the inside will remain relatively dust-free. We'll see. I have not included a cooling fan in the box, but that may be something I add later if it gets too hot in there. The square holes you see on the front panel are for the remote panel of the VFD and 2 power switches, one for the computer and the other for the CNC modules. Well, that's the design. The proof will be in the pudding, of course, so come back next time as we start the build. Thanks for watching, and please hit the subscribe and notifications buttons, and we'll see you next time.